How to create animated stories using ChatGPT's new image model. Hey guys, in today's video, I'm going to show you something super exciting: how you can use the new image generation model inside ChatGPT to create short animated stories with consistent characters, scenes, and style all the way through. We're not just making random images here, we're building a full, coherent animation sequence from scratch. When it comes to creating a full animated story using AI, there are several key components you'll need to bring everything together. And the good news is that ChatGPT can actually help with each step of the process. First, you'll need a script. This forms the backbone of your animation: the storyline, the pacing, the dialogue, everything. Once you've got a solid story written out, the next step is to figure out your characters. You'll need to think about who your characters are, what they look like, how they behave, and even how they interact with each other. ChatGPT can help you describe their personalities and physical features in detail. This is crucial for generating consistent visuals later on. Once you have your characters, it's time to break your script into individual scenes. For each scene, you'll want to create a shot list, basically a breakdown of what shots or visual angles you'll need to capture the action. This could include things like wide shot of the forest, close-up of the main character's face, or over-the-shoulder view during conversation. Each of these shots will then need its own text-to-image prompt, which you'll use with ChatGPT's image generation capabilities to create visuals that match your script. After that, you'll need to animate these static images. This is where an image-to-video tool comes into play. For each image, you'll write a short prompt that describes how the animation should behave. For example, the boy waves goodbye as the sunset fades behind him. You'll use this in a video generation tool like Runway, Pika, or HeyGen to turn your still image into a moving shot. If any of your scenes include dialogue, you'll also need to generate voiceovers. That's where text-to-speech tools like 11 Labs, PlayHT, or Descript come in. Simply take the dialogue written in your script and run it through a voice generator to bring your characters to life with natural-sounding speech. Now there's a custom GPT that created just for this purpose. It's called Animation Script Builder, and it's designed to help streamline the entire process I've been talking about. You simply tell this GPT what kind of animated story you want to make, whether it's a short scene, a full narrative, or even just a sketch idea, and it will break everything down for you. It'll generate your scene scripts, create character descriptions, come up with a shot list, and even help you form the right prompts for generating both images and animation. Like most AI tools, it's not going to give you a Hollywood-ready script and animation plan straight out of the box. But what it will do is give you a super solid starting point, the kind of foundation you can tweak, adjust, and build your creative project on top of. So here's how to get started using it. First, head over to chat.openai.com, and on the left sidebar, click on the Explore GPTs button. Once you're in the Explore section, just type Animation Script Builder into the search bar. You should see it pop up. It's the one created by E. Emmanuel Crown. Click on it, then hit Start Chat. Now you're ready to go. In the chat box, go ahead and describe your project idea in as much detail as you can. If you already have a script written, paste it right in. Or if you're starting from scratch, just type out your concept. Include what the story is about, what kind of characters you want, the tone, the setting, anything that might help the tool get a clearer idea of what you're aiming for. In my example, I decided to keep things really simple, just to do a quick test. So I typed in a basic prompt: write a 3D cartoon animation script about a boy getting ready for school. I know it's super vague, but that's kind of the point. I wanted to see how well the GPT could handle a general idea and flesh it out into something more complete. As soon as I submitted the prompt, the Animation Script Builder GPT responded with a few smart follow-up questions. It asked me how many characters I wanted in the script, what the boy should look like, whether there are any additional characters in the scene, and even my preferred animation style. Since I'd already mentioned 3D, that part was covered. I replied with something simple, Let's have two characters, the boy and his mom. You can go ahead and come up with the rest of the details for me. I was just experimenting, so I didn't want to spend too much time inputting all the specifics. But you could definitely be more detailed here if you already have a clear vision. What happened next was pretty cool. The GPT immediately got to work and started by generating detailed descriptions of the characters. It provided visual traits and personality notes for both the boy and the mom, which is incredibly helpful when it comes to consistency in animation. This is the kind of info you'd want when prompting an image model to generate your characters visually, especially if you want them to appear consistently across different scenes. Once I had those character descriptions, I told the GPT, now go ahead and create the image prompt for the boy, the first character. It responded by writing a text-to-image prompt I could use in tools like DALL-E or any image generation model. That said, it still gave me a solid prompt to work with. And even though this is a quick test, you can see how this GPT acts like a production assistant, giving you prompts for characters, environments, and eventually even animation-ready assets. For now, though, here's what I did. I simply continued the process within the GPT chat and asked it to generate a script for scene 1 of my animation. Instead of trying to write the whole thing in one go, I'm going scene by scene, which helps keep everything more organized and manageable, especially when generating visual content to match. As soon as I gave the instruction, the GPT broke down scene 1 beautifully. It laid everything out in a very clear format. First, it described the setting and mood of the scene. Then, it wrote the script narration, which could either be voiceover or dialogue, depending on your animation style. What's super helpful is that for each shot, it also provided a scene description that explains what's happening. A text-to-image prompt. This is the prompt you can paste into any AI image generator, like DALL-E 3, Midjourney, or Leonardo AI, to generate a visual for that specific shot. An image-to-video prompt, which is meant for tools that turn static images into animations, like Runway ML or Pika Labs. All I had to do is copy the text-to-image prompt into my preferred image generator and then take the result and animate it using the image-to-video prompt. That's how I got a working visual for scene 1. Everything we've done so far looks solid, and now it's time to move into the visual side of things. But instead of continuing to generate images right inside the same GPT chat we've been working in, which still uses the older DALL-E model, we're going to take a more effective route. Here's what I recommend doing. Take all the content generated so far, including your full script, scene breakdowns, prompts, and especially the character descriptions. Those are important for visual consistency, and copy them. Then head back to the ChatGPT homepage and start a brand new chat. Once you open that new chat, be sure to switch your model to GPT-4o. That's the latest model, which includes the upgraded image generation capabilities. It's more powerful and will give you far more visually appealing and consistent character outputs. That's exactly what we need for building clean, cohesive, animated sequences. Now, in that new GPT-4o chat, go ahead and paste everything you copied earlier. At the very top of that message, make sure to include the detailed descriptions of your characters, like what they look like, how they dress, their personality traits, etc. This will help GPT-4o generate images that align more closely with your vision and maintain visual consistency across scenes. The reason for this whole workaround is simple. At the moment, custom GPTs don't yet have access to the newest image generation engine. But GPT-4o in a regular does, so this method gives you the best of both worlds, the structure and guidance from the GPT and the visual power from the latest tools. Once you're set up in the new chat, you can start pasting in scene-by-scene prompts, requesting image generations that match each shot, and even tweaking them with references or descriptions to maintain the same style throughout. That's really the only reason we're taking this slightly roundabout route right now, because once the latest GPT image model is fully supported inside custom GPTs, you'll be able to keep everything inside a single workflow. No need to switch chats. But until that happens, This is the best workaround to get stunning, consistent visuals for your animation. Now that we're in the new GPT-4o chat with all of our character descriptions and scene outlines pasted in, we can start building the actual images. First, I'm going to enter a prompt to generate a front-facing image of our main character, set against a clean white background. This gives us a good base visual for introducing him in the story. Once that's done and we're happy with how he looks, I'll repeat the same step for the mom character, to maintain consistency in style and lighting. After we've generated and finalized these character images, it's time to build out the visuals for the rest of the animation. If you remember, the animation script builder GPT already created a detailed shot list for each scene, including what each shot should look like. All we need to do now is take those descriptions and turn them into image prompts. So next, I'll take the first shot description from scene 1 and input it into GPT-4o with a specific request. Something like create an image of shot 1 as described in a 3:2 aspect ratio. The 3:2 format is currently the widest output GPT-4o supports, which gives us something close to the standard 16:9 look used in most animated videos, while still maintaining high image quality. I'll continue this process for each shot, using the script and prompts from the earlier GPT, making sure everything lines up with the story and the characters we've already established. Here's what the result looks like so far. The image for shot 1 has been successfully generated, and once that was done, I simply moved on to the next by typing create the image for shot 2. After that rendered, I followed the same process for shot 3, then shot 4, and so on, going through the entire list of shots that were included in the script. It's a rinse and repeat approach, but it works really well. By the time I finished, I had a full set of images for all the key moments in my animation. What's great here is that despite generating each image individually, the AI maintained impressive visual consistency across the board. Both characters looked the same in every scene, same hairstyles, same clothing, and even the room details like the bed, window, and wall color stayed cohesive. I didn't have to manually retype or redescribe every tiny detail in each prompt because ChatGPT remembered the full context of the conversation, which saved a ton of time. That said, it's worth noting that this level of consistency tends to work best for shorter scripts. If you're building a much longer animation, say with 8, 10, or more scenes, you might start to notice some visual drift in character details or scene settings. This isn't a bug, just a result of the model's memory window being exceeded over time. But don't worry, there's an easy fix. If things start to look inconsistent, simply reintroduce your key character images into the prompt. For example, you can say, generate the image for scene 10 using this picture of boy as the character, and paste the reference image or description back in. This helps the AI refocus and continue generating shots that match your original character designs. All right, so now we've made it through the image generation process. We've got all the visuals ready for every scene, and the characters are looking consistent throughout. The next major step is to breathe life into these static images by turning them into animations. This is where the fun really begins. There are a bunch of tools you can use to animate AI-generated images, but in this particular walkthrough, we're going to focus on two standout platforms that work especially well with the 3D-style, cartoonish visuals we just created. Kyber AI, also known as Kling AI in some communities, and Runway Gen 4. Both of these tools are excellent for turning still images into smooth, stylized animation clips, especially if you're working on character-driven stories. So here's what I did next. I opened up Kling AI, and once I was on the dashboard, I clicked on the Upload Image option to start animating one of my scenes. Now, when you're uploading your image, you'll also need to give Kling AI a prompt. This is basically a short description telling the animation engine how you want your character or scene to move, what kind of action to show, or what vibe to convey. And this is where our custom GPT comes in handy once again. Remember earlier when it generated each scene? Along with the text-to-image prompts, it also included image-to-video prompts, which are tailor-made descriptions meant for use with animation tools like this. So instead of having to sit and craft a whole new prompt from scratch, all I have to do is go back to the original GPT conversation, grab the pre-generated animation prompt for that specific scene or shot, and paste it right into Kling AI. It's super efficient. The GPT already did all the creative heavy lifting. I just need to feed that into the animation tool, adjust a few settings like duration or motion type, and hit generate. Once you've done that for one scene, you can move on to the next image and repeat the same process until every shot has been turned into an animated clip. Before long, you'll have a full sequence of animated scenes ready to stitch together into a short film. All right, so let's move on to the animation part of our process using Kling AI. Now, for shot 1, we already have a ready-to-use image-to-video prompt that was generated earlier by the animation script builder GPT. Before hitting the Generate button, though, I want to quickly talk about Kling AI 2.0 because it's a big part of the conversation right now. If you haven't heard about it yet, it's their upgraded animation engine, and yes, it's pretty impressive in certain areas. From my experience, it really excels when your scenes include complex motion, like action sequences, sweeping pans, or quick transitions. It's much more responsive to those high-energy prompts compared to version 1.6. However, if you're working with simpler, slower-paced shots, especially ones based on AI-generated illustrations that are already somewhat stylized, the difference between 1.6 and 2.0 isn't always dramatic. Kling 1.6 still does a great job bringing static scenes to life, especially when you're just adding minor animations like zooms or subtle character movement. So depending on what kind of scene you're animating, feel free to test both versions. For this particular zoom in on shot 1, I decided to use Kling 1.6 because it handled the prompt nicely without over-complicating things. Hit Generate, and within a few minutes you'll have a polished animated shot ready to go. Super easy, and all thanks to how everything connects through the GPT prompt-to-image workflow. That said, here's my advice. For most of your standard scenes, especially static or semi-static ones where there's little camera or character movement, Kling 1.6 is often more than enough. It's more credit efficient, and in many cases, it gets the job done just fine. In fact, for my project, I used Kling 1.6 for the majority of the scenes. Once you finished rendering all the animated shots using the appropriate versions of Kling AI, I had a complete visual sequence for the story. The next step is to generate dialogue audio for the scenes that include character interaction or narration. This helps bring the scenes to life and gives your story more emotional impact. All right, now that we've got the narration or character dialogue ready, let's say for scene whatever you like. We'll go ahead and copy that entire line of dialogue and paste it into a text-to-speech generator. I personally prefer using 11 Labs because it's fast, natural sounding, and works incredibly well for character-driven narration. Once I've pasted the line into 11 Labs, something like, "Time to wake up, sweetie," hit the pause icon, and within seconds, I've got a clean audio file for the scene. It sounds warm, expressive, and perfect for the tone I'm going for. Now comes the interesting part, syncing that voice to the character's lips. Kling AI actually gives us a lip sync option right within the interface. While it might not be Pixar-level accurate, it's surprisingly effective for short animated scenes. So for example, what I'll do next is click on the lip sync option. Then I go to Upload Local Audio and drop in the audio file we just generated from 11 Labs. You can use any voice, your own, a voice actor's, or anything else that suits your story. Once that's uploaded, les the rest. The end result is a short animation where Mom appears to be saying the words in the voice we just created. Simple, quick, and surprisingly convincing. So if you're looking for a completely free way to animate your scenes with lip sync, just a heads up, Runway ML might not be your best bet. It's incredibly powerful, but many of its best features, including consistent access to Gen 4 and lip sync options, are locked behind a paywall. That said, let me walk you through exactly how to replicate what we just did in Kling AI, but using Runway ML instead. First, head over to Runway ML, log in, and from your dashboard, click on Generate Video. This will take you to the video generation interface where, similar to Kling AI, you'll be prompted to upload an image, your character or scene still, and input a prompt to animate it. This is where the prompt generated earlier by your GPT comes into play. Now, when you're choosing your video model, Gen 4 and Tobo are two of the most recommended for this kind of stylized animation. They tend to handle artistic and 3D cartoon imagery really well. Once you've selected the model, paste in your prompt. Upload your image and hit Generate. Give it a moment and you'll see the animated video clip appear. Now let's talk lip sync. Runway gives you two methods to add lip sync to your animated clips. Built-in lip sync tool. Once your video is generated, click on the Actions drop-down menu. You'll see an option called Lip Sync. Click that, and Runway will attempt to auto-detect any human faces in the clip. Once a face is recognized, it'll prompt you to upload your audio. This can be your own voice recording or an AI-generated narration from tools like ElevenLabs. After the audio is uploaded, click Generate Lip Sync, and Runway will animate the lips to match the voice. To see how it compares, I test the scene. Here's how both platforms handled it. Kling AI version, smooth visuals, but lip sync can feel a little off depending on the clip. Where Runway version, slightly more refined mouth movement with better timing on speech, though sometimes less flexible visually. Lip sync tends to work best when you're actively driving the performance, so anytime it clicks, it feels natural and immersive. One of the best ways to do that is by using Runway ML's Act 1 tool. Let me walk you through how to use it for full performance-driven lip syncing and facial animation. Start by heading back into your Runway ML dashboard and click on Act 1. This tool is designed for expressive animation using real human performance as the driver. The first thing you need to do is upload either an image or a video of your character. If your character already has some movement, like a head tilt or sip of coffee, it's better to use a video. This way, you're not just animating the mouth, but enriching the entire shot with emotion and realism. So in this case, I'm uploading a clip, something we generated earlier in Kling AI. Runway will take a few seconds to analyze the footage and detect the character's face. Next comes the performance part. You'll need to either record yourself live or upload a pre-recorded video where someone delivers the lines you want the character to say. This acts as the facial and lip sync reference for the tool. You can record this in real time. The result? Runway uses facial expressions, head movements, and lip sync as a performance template to animate the face in the clip I uploaded. It's basically like puppeteering your animated characters using your own expressions. Now, about the voice. If you're wondering how I made the mom's voice sound different from mine, that's thanks to ElevenLabs. Inside ElevenLabs, just go to the Voice Changer tab. Upload your original audio, choose one of their pre-trained voices, or a custom one you've created, and hit Generate. It'll transform your voice to match the tone and personality you want, whether that's warm and motherly or sharp and dramatic. And there you go. Once all your scenes are ready, animation's done, and lip sync's perfected, the last step is to assemble everything. You can use any video editing software you're comfortable with, like CapCut, Adobe Premiere, or DaVinci Resolve to bring it all together. Import your scenes, align the narration and animation, add music or sound effects, and you've got a polished AI-powered animated short film. All right, so for this tutorial, I decided to go with CapCut. You can grab CapCut from CapCut.com for desktop or use it right on your phone. It's super accessible. Once I opened CapCut, I dragged all my generated video clips right into the timeline. From there, it's just a matter of trimming and arranging each scene in the right order. You can use the blade tool to cut out anything you don't need and reposition clips with a simple drag and drop. Follow the sequence scene by scene to keep the story flowing smoothly. It helps more than you think with YouTube's algorithm. That's it for this video. Hope you found it helpful. Hit like and subscribe for more tips and tutorials like this.